Okay, so what I'd like to do is talk about just the work I've been doing in analysing the microlensing survey fields towards the galactic bulge with PRIME. So you've already seen all the details of the PRIME instrument, so I'm not going to, and the telescopes, you've seen all that described, so I won't repeat it here. Just quickly summarise a few relevant points there, and I won't even read that out. The other thing to say is, effectively the Galactic Bulge Survey started in 2024. Okay, and we got 35 target fields defined there. And mainly the main survey passband is H, and that's the passband I've been working with. I haven't done anything yet with the other passbands, but I hope to do that. And so just to summarise a few issues, a couple of issues I struggled with, non-linearities and hot pixels. But I think I've overcome those. And what motivated me was what I wanted to do was just try to implement. I was motivated by what I implemented for MOA. So I wanted something similar to that. Based on the difference imaging analysis technique there. And the other point I'll make, I use the 2MASS catalogue for astrometric and photometric calibrations. So that's okay. So that's the image of one of the fields that straddles the galactic centre from one of the chips, and it's actually this was done in a dither pattern offset. So this actually helps deal with the hot pixels there. So that's a median stacked image that we've got. So we use that and the same images for all the other fields as our reference image for the difference imaging procedure. And so I've just marked in there. That's the actual galactic coordinate frame origin there, and then I've also marked in Sagittarius A as the actual galactic centre. Okay, so that's from one chip. And so here's a mosaic of four of the CC. Oh God, they're not CCDs. So I've got to stop calling them CCDs. I just can't help it. This is from working with MOA so much. Okay, so these chips. And so these are the four chips there, and so they're all showing their correct positions and orientations there. So this is the paw print, so to speak, from one prime in one prime exposure there. So and this is the field that straddles the galactic centre there. And what I've also done is just made a mosaic of all of the 35 target fields. So our fields are defined in this 5x7 grid, and so all these other fields have been labelled as well. So I've just marked in the one by the galactic centre, and what I've also done is just marked in the the overlapping MOA fields as well. And it's interesting to compare. To compare the infrared and optical observations. So here is so this is one of the prime fields in H, and this is and these are the MOA, the overlapping MOA R band images that that overlap that field, and they've been just resampled to fit that prime H band coordinate frame there. So you can see all the clouds there obscuring in the MOA R band, but it looks like we've got some penetration through those clouds in the infrared. And it summarises a very simplified overview of the data flow, similar to what was used for MOA. One difference here is that we take our observations in sets of offset dithers they'll have between 6 to 12 consecutive observations, but each one just slightly offset. And so that deals with the hot pixels and the bad regions And so the idea is we have an input to the set. So these are the inputs there are the ramp images from the USA's procedure. And then they're geometrically aligned and then median stacked. And then we create a difference image by comparing with the appropriate reference image. You get a difference image and then look for anything that's interesting on the difference images, like that. And so just summarize the results. So I wasn't trying to issue actual real-time alerts as we're doing with MOA, but that will be we'll hopefully we'll be able to implement that in 2025. So I've got just under 300 events found. I've put them up. I've displayed them at those links there. And yeah, I've also got a MOA and PRIME field finder as well. So your favourite target and see if it's in the survey fields. Okay, so we've got 284 retrospective microlensing alerts, and I'll just show just a few of them. So I'll just show some samples here. These are the ones which have MOA counterparts. So so this one here, well, I'll just show them. Don't need any explanation there. There's another one there, and another sort of low magnification one, and another low magnification, and this looks like some sort of binary event. So we see a few binary events there, but I'm not able to say anything about whether these are actually planetary microlensing at this point. So I don't have any information on that. And I'll just end by talking about variable stars. I didn't realise I've looked at so many. But we tagged about that number of variable stars there. And I'll just show, well, I won't show all of them, but I'll show a few of them. So I just wonder if these are the Miras that we just heard about in previous talk. And these are long period timescale variables there. And then some sort of semi-periodic or perhaps semi-periodic variables. And so the 10-day periodic variables there, some other types sort of periodicitors there, and some sort of weird-looking things that I don't really know what they are. But finding all sorts of all sorts of types of variables in the PRIME data set, and then some more rapid variables have shown up there as well. So you see that's where if you look at the time sequential light curves, it's not obvious what the period is. You can just do a simple periodicity analysis, then look at the phase folded light curves underneath in the bottom panels of each bottom sub panels there. So yes, they look like contact binaries perhaps. And then there's some on the issue of binaries. There are quite a few eclipsing binaries, of the detached type have shown up amongst the PRIME images as well, amongst the PRIME data set. So here's a sample of some there. So some where you can clearly see primary and secondary eclipses, and others where it's not quite so obvious. And yeah, I'll just end with just have a look at the galactic center vicinity as well, because that's sort of quite interesting. And so these are these are variables that I've tagged around the galactic center vicinity, and you just look at 1432 just over there. I thought it was microlensing at first, but I'm not sure that it is. But some sort of transient behavior there. Okay, so all right, so that's it. So so just the conclusion I'll make from this is that now we can get light curves from our prime microlensing survey observations. So I'll stop. Yeah, I've finished. Right, thank you.
Thank you very much, Ian. So we have a question already. It's very nice. The VVV people identified a group of stars, I think they call them dipping stars, that is seen through high reddening towards the galactic centre, late-type stars, but not pulsating. Have you identified similar things?
Maybe they might be amongst those 13,000. If I knew what they looked like, I'll.
Yeah, a question on the image suppression. You mentioned that what is affecting image suppression is like rate of error and nonlinearity. How important those are, because on the images that somebody else showed, you're processing actually, you're blocking out the central part.
So that's it seems like those are just the saturated stars. So I've been a little bit conservative in setting the sort of brightness threshold for this analysis. So yes, the ones that I've blotted out are the brighter stars. So they're either saturated, or they're stars where this BFE effect is becoming quite serious. Yeah. And there was quite a bit of trial and error involved in that.
And on the brighter pattern, what we know from Roland team, brighter pattern starts being noticeable at the saturated level.
Right.
But do you see anything else?
I don't. It looks like it's it looks like this BFE effect is not really affecting things below the saturation level. I mean, just looking at the different images, they seem to be coming out all right.
I see we have one question online. Wei Cheng Zhang, if you want to unmute and ask your question.
Okay, thanks. Hi, Ian. I have a question. And for the macro event observed by both PRIME and MOI, is PRIME's photometry accuracy higher than MOI or lower?
Well, we can just do a direct comparison. They look to be comparable.
Okay.
Yeah, so it looks like PRIME and MOA are. That was that was the impression I was getting, that the PRIME and the MOA photometry are comparable in accuracy.
Okay. Thank you very much.
By and large.
Okay.
Did you also find any Kuiper belt objects in your data? And how did the Kuiper belt objects?
Kuiper belt.
I was thinking about that because you showed the bump in the galactic center.
Right.
Whether it could be also something.
Yeah, I just haven't given that any thought. Kuiper belt ones. I doubt that's what they are. I mean, because I thought about doing that with MOA. And well, I'll just say with MOA, we do see some TNOs there. But what I just showed, I don't think it's a Kuiper belt object.